This is the review video for solving rational equations found in Chapter 5. Our first equation, one of the first things we look for with rational equations is if there can be any factoring. In this case, the numerators definitely cannot be factored since they're just numbers. And in the bottom, denominators, there's no GCF and there's no x squared or higher, so we can't go any further. Since we have two fractions here that are set equal to each other, I would recommend doing this one by cross products. So we'll multiply 4 times x minus 4 and set that equal to the other cross product, which would be 2 times x plus 2. Now we're going to distribute on the left side, so we're going to multiply by 4. So I have 4x, and then the 4 times negative 4 is negative 16, equals, distribute on the right, 2 times x is 2x, 2 times 2 is 4. Now we have like terms, our x's, but they're on opposite sides of the equal sign, so we have to do the opposite. So I recommend moving the smaller one over to keep things positive, and the smaller one would be the 2x. Since it's a positive 2x and I have to cross the wall, we're going to do the opposite, so we're going to subtract it. 4x minus 2x is 2x. Bring down the minus 16. Cross out the 2x on the right, and we're left with a 4. Now that my x is on the left side of the wall, the equal sign, we need to move everything else to the other side. So we start with the minus 16. To get rid of that, we're going to add 16. So I have 2x is equal to 20. To get x by itself, we divide both sides by the 2. So x equals 10. And there's answer number 1. Second problem, we no longer have just two fractions, we've got 3. And obviously the first thing we check for is factoring. Well, if I look at the denominator of the first fraction, I can factor m squared minus 25. This is one where m is perfect, m times m. 25 is perfect, and it has the minus, so this one does work. So m squared minus 25 will become m plus 5 and m minus 5. So I look at my fractions, and my roster members are the different parts of here. So I have an m plus 5, an m minus 5. Here I have an m plus 5, but I already have that written. And here I have an m plus 5, and I already have that written. So these are my roster members. So every fraction has to have both of these players in their denominator. And once we have that, we can then just work on the numerators. So I look at my first fraction, and it has m plus 5, and it has m minus 5. So he doesn't need anybody new on his team, so we're going to leave that numerator alone. The second fraction has the m plus 5, which means he needs the m minus 5. So that's what we have to multiply the numerator by. The third fraction has an m plus 5, so he also needs an m minus 5. My first numerator, we don't have anything to multiply them by, so it's going to stay in m. Bring down the plus. When I take the 10 times m and times minus 5, I get 10m. And then 10 times negative 5 is minus 50. Equals. On the other side, I need to distribute 15. 15 times m is 15m. And then 15 times minus 5 is negative 75. I've got like terms on the left side with an m plus 10m. So that's 11m, because they're on the same side, so we add them. And now my like terms are on opposite sides. So I'm going to move the smaller one, which is the 11m. And since it's positive, I'm going to move it by subtracting it. The 11m's cancel, so I'm left with negative 50 equals 4m minus 75. Now the m is on the right side of the equation, so I need to move anything else that's over here to the other side. So I first start with this 75. Since it's minus 75, I'm going to add 75. Negative 50 plus 75 is 25, equals 4m, and the 75's cancel. M is still not by itself, so now we divide by 4. It is perfectly acceptable to leave these answers as fractions. The only thing you have to check for is if they can be simplified. 25 and 4 have nothing in common, so 25 over 4 is the answer. If you did change this to a decimal, then you would have 6.25. And there's answer number 2. Number 3, once again I look at how many fractions I have. I have 2 fractions and a whole number, but I can change that 5 into a whole number by putting it 5 over 1. So now I need to look at my roster members again. In the first fraction, I have a w. In the second fraction, I have a 3 times w. Well, I already have the w, so the only number I need to add is 3. And the third fraction, I have a 1. Well, multiplying by 1 doesn't change anything, so I call him a useless member. He's the bench warmer. We don't actually need him. So, in the first fraction, I have a w out of my roster, which means I need the 3. The second fraction has the 3 and the w, so he doesn't need either of them. The third fraction just has a 1, so the 5 needs both the w and the 3. So now the first one, we're going to go 4 times 3, which is 12, minus the 1 because we're not changing the second fraction. And then the third fraction, we multiply 5 times w times 3. Well, 5 times w is 5w, times 3 is 15w. On the left side, 12 minus 1 is 11. W now needs to become by itself, so we're going to divide both sides by 15. 11 can't be divided by 15. It also can't be simplified, so our answer is 11 over 15. Number 4, the first thing is the equation is not made up of x's, so we need to say what value of a makes the equation true. And that just means we need to solve this. So if we see 3 fractions, there's nothing that I could factor, no exponents, no GCFs, so I start with my roster member. The first fraction has an a, so he's part of the team. The second fraction has an a plus 3. Well, plus is different than times. And a plus 3 can't be separated like 3 times w could in the last problem. So our second member is a plus 3. The third fraction has an A, and we already have an A in the roster, so we've got all of our roster members. So the first fraction has an A, so he needs an A plus 3. Second fraction has the A plus 3, so he needs the A. And the third fraction has the A, so he needs the A plus 3. So now we distribute our first one. So we go 2 times A, which is 2A, 2 times 3, which is 6, plus 3 times A, which is 3A, equals 8 times A, 8A, and 8 times 3, which is 24. Got lots of A's here, so we're going to start simplifying them. So we first start with our same side, 2A plus 3A, that's 5A, plus 6 equals 8A plus 24. Now our variables are on opposite sides, so we need to get them together. So I'm going to take the 5A and subtract it to the other side. So I now have 6 equals 3A plus 24. Since I've moved my A's to the right side, I need to make sure I get everything from the right side over to the left. So we start by subtracting 24. So I have negative 18 equals 3A. This is 3 times A, so to solve we need to divide by 3. Negative 18 divided by 3 is negative 6 equals A. Number 5, it says if x does not equal 3, or actually in this case, I should say x does not equal negative 2. And the reason it states that is you can't have a 0 in the denominator. It wants to know what would happen after the first step. So first thing we look for is if there can be anything factored. There's no x squareds, there's no GCFs, so the answer to that is no. I've got the 5 as a whole number, so I'm going to turn it into a fraction, and I'm going to look for my roster members. Well, the first fraction has an x plus 2. The 5 has a 1, and remember that's that bench warmer, we don't really need him. And the third fraction has an x plus 2, which is already a roster member. So he's the only member on the team. So the first fraction already has him, so he doesn't need it. 5 doesn't have him, so we do need to add him to the 5 by multiplying. And the third fraction also already has x plus 2, so we're going to leave that the same. So the first step would be actually doing the multiplying. So the 4x comes down. We then know that we would be taking 5 and multiplying him by x plus 2. And then we have minus 10. So this would be the equivalent expression after the first step, after we did find the common denominators by changing our numerators. Number 6, we're back to solving. So again, look for how many fractions and if there's any factoring. No factoring once again. No t-squareds, no GCFs, so we don't have to worry about that. So we start with roster members. First fraction has a 5. Second fraction has that 5 times t. Well, 5 is already here, but t isn't, so I'm going to bring a t. Third fraction has a t, but we already have a t, so 5 and t are my roster members. So the first fraction has the 5, but needs the t. Second fraction has 5 and the t, so he doesn't need anybody. And the third fraction has t, which means he needs the 5. So we've got 1 times t, which is t, plus 2, because the second numerator didn't change, equals 17 times 5, which would be 85. T is on the left side, and we need to get it by itself. There's a plus 2, so we're going to subtract 2. So t equals 83. T is by itself, so there's my answer. Number 7, we're still solving. This one we could actually do a couple of different ways. I'm going to show you the easiest way. Yes, you could make them have the same denominator by roster members, but notice how the 10 and 34 are both whole numbers. So before I do anything, I'm going to take that plus 34 and subtract it over to combine with the 10. 10 minus 34 is negative 24, and that's now equal to 5 over w. So now I've got a number on the left and then the fraction on the right. So I'm going to turn this into a fraction now, and whenever I've got two fractions set equal to each other, typically the easiest way is to cross multiply. So I have negative 24 times w and then I've got 1 times 5, which is 5. W has the negative 24 attached to it, so I'm going to divide both sides by that negative 24. So W equals negative 5 over 24. Number 8, I've got a fraction on the left that can't be factored and a whole number on the right. So I'm going to change that 5 to a 5 over 1. And now that I've got two fractions that are set equal to each other, I'm going to cross multiply. So I have 3 times 1, which is 3, equals 5 times a plus 7. So I'm going to distribute on the right. 5 times a is 5a. 5 times 7 is 35. And it's still equal to 3 on the left. Since a is on the right, I need to move everything over to the left. So minus 35. 3 minus 35 is negative 32. Equals 5 times a. Divide both sides by 5. 32 and 5 cannot be simplified, so a equals negative 32 over 5. Number 9, first thing I look for is to check for factoring. This time I actually do have something I can factor. M squared minus 16, that factors into m plus 4, and m minus 4, sorry. I could cross multiply this one, but since I've got two terms in the bottom right, two of those parentheses, that would actually make this one harder. So I'm going to go by roster members. So typically if you see two parentheses in one fraction, roster members will be your best bet. So I've got a roster member of m minus 4, and a roster member of m plus 4, and then m minus 4, which is already written. So these are my two roster members. The first fraction has m minus 4, so he needs the m plus 4. The second fraction already has both, so we don't need to multiply it by anything. So I now have 3 times m plus 4 is equal to 2. Distribute my 3. So I have 3m plus 12 equals 2. And now I can start solving for m. Since m's on the left, we need to clear everything from the left to the right. So I'm going to subtract 12. So I have 3m is equal to negative 10. M is still not by itself, so now I'm going to divide by 3. So m equals negative 10 over 3. First thing I look for is anything that can be factored. No GCFs, no x squareds, so I can't factor. Next, I look at how many fractions. There's 2 here set equal to each other. And since there was no factoring and no multiple parentheses, cross-multiplying is what we're going to go back to. So my first one is x times x plus 1 equals the other cross product, which will be x times x minus 1. Distribute on the left, x times x is x squared. X times 1 is 1x, or just x, equals, on the right, x times x is x squared. X times negative 1 is negative x. Well, the first thing I notice is my x squareds are on opposite sides and they're exactly alike. So if I were to move them together, they would cancel out. So I'm going to go ahead and cross them out. So I'm left with x is equal to negative x. Well, these are not exactly alike, so they don't cross out. So I'm going to take that negative x and I'm going to add it to this side. So I'm going to go plus x, opposite of a negative. Well, x plus x means 1x plus 1x, so that's 2x. On the right, negative x and x cancel, which leaves me with 0. And remember, 0 is an okay answer. It's a number just like any others. So the x is not by itself yet, so I'm going to divide both sides by 2. 0 divided by anything is 0, so x equals 0 is this answer. Number 11, still checking for factoring. No GCFs, no variable with an exponent of 2 or higher. So now I look at how many fractions. I've got 3 fractions here, so we're looking for roster members. First denominator has a 3, so there's roster member 1. Second one has a y, so there's member 2. Third one has a 2. Which is not part of the roster yet. So this time I have 3 roster members. The first fraction only has the 3, so he needs the other 2 members. So times y times 2. Second fraction has the y, so he needs the 3 and the 2 for part of his team. Third fraction has the 2, so he needs the 3 and the y. So now we start multiplying. First one we go 2 times y, which is 2y, times 2, that makes 4y, plus, here I've got 2 times 3, which is 6, times 2 is 12, equals, and on the right hand side, 1 times 3 is 3, times y is 3y. And now we start solving. Typically we would move the 3y over since it's smaller, but if I move it over, there's nothing left here. So I'm going to go ahead and move the 4y over. And it's positive, so I'm going to subtract it. So I have 12 equals negative 1y. Y is not by itself yet, so we're going to divide both sides by negative 1. So I have negative 12 equals a positive y. Last question on our warm-up, on our review for this. First thing I look for is anything that can be factored, and I see an x squared, so I know that I can factor x squared minus 4. That turns into x plus 2 and x minus 2. Next thing I look for is how many fractions. I've got 3 fractions, so I'm looking for roster members. First denominator has an x minus 2, so there's roster member 1. Second has an x plus 2, there's roster member 2. Third one, x plus 2, already part of the list. X minus 2, already part of the list. So my first fraction has x minus 2, so he needs the x plus 2. Third fraction has x plus 2, so he needs x minus 2. And the last fraction has x plus 2 and x minus 2, so he doesn't need anybody. His team's complete. So I distribute 2x to x, which is 2x squared. 2x times 2 is 4x. Second fraction, 2x times x is 2x squared. 2x times negative 2 is negative 4x, and that's equal to 3. Looking for like terms on the left-hand side. Well, I've got a 2x squared and another positive 2x squared, so that's going to make 4x squared, 2 plus 2. Then I've got a positive 4x and a negative 4x. Well, 4 minus 4 cancels, so they're gone. And so this is now equal to 3. Start solving for x, so we got to divide both sides by 4. So I now have x squared equals 3/4. X squared is not an x by itself yet. The opposite of squaring something is to take the square root. And whenever I take the square root, I don't know if they wanted the positive or the negative answer of it. So my answer is plus or minus the square root of 3/4. And that's answer number 12 of the Solving for Equations review as part of Chapter 5.